Hi, my name's Avery. I'm one of the technical advisors here at SYSTEM. And one of the questions I get asked all the time is how much fiberglass do I need for a repair? And my answer is, it really depends, because you gotta consider the thickness of your final laminate, because the thickness of your laminate is going to drive the stiffness of your laminate. Let's simplify our repair area down to a simple beam. When a beam bends, the areas furthest away from the center, the top and the bottom, are going to experience the most stress. That's because the material on the top and the bottom are going to need to stretch or compress more than the material that's closer to the center. The further a material is away from the center, the more it will want to resist that deformation. In a thicker beam, there's going to be more material further away from the center, and thus a thicker beam is going to be harder to bend. All things consistent, a thicker laminate is going to be a stiffer laminate. That's why we always recommend that you match the thickness of your repair to the thickness of your original surface. This helps create even stiffness across the entirety of your repair and helps limit future failure points. So let's say we're repairing a fiberglass boat. We've measured the thickness of our original laminate and need to know how many layers of what weight fiberglass to use. To do this, we need to know what the thickness of one wet out layer of fiberglass is. As an engineer, I will calculate that out using this equation. To spare you from doing the calculations yourself, we've created a chart that provides the average range for a single layer of fiberglass fully wet out. This chart does assume that the fiberglass is fully and properly wet out and you're using a hand lamination technique. The chart does provide a range because there are a myriad of different variables that affect the final thickness of your laminate. One of them is going to be the technique that you use to wet out your fiberglass. For our chart, we specify that it's a hand lamination technique as compared to a vacuum bagging technique. When you use a vacuum bag to compress your laminate, you're going to get a thinner final product. Here we're wetting out 5 layers of our 737 17-ounce fabric. One using a roller and a spreader, the other using a vacuum bag to get extra compaction, using 15 inches of mercury of vacuum. After the panels were cured and cut, we discovered that the vacuum bag panel is about 60% the thickness of the panel that didn't experience any extra consolidation techniques. This goes to show that vacuum bagging greatly reduces the thickness of your laminate and means that the chart isn't really applicable for that kind of application. Viscosity is also going to have an impact on your final laminate thickness. As it gets colder outside, your epoxy is going to get thicker and more viscous, making it harder to compact those layers closer together. The same is true as the epoxy gels. The viscosity is going to increase, making it harder to compact. Finally, manufacturing variance can also play a role. Even a slight manufacturing variance when dealing with such thin layers could have an impact on your final thickness. Alternatively, if you don't want to use the chart, you can build something called a thickness gauge. Here's a thickness gauge that we built, going from 1 layer up to 10 layers of 10-ounce glass. These are especially handy if you're going to do multiple projects with the same type of glass. You can quickly measure your laminate, measure the thickness gauge, and know how many layers of glass you're going to need for that repair. So as we mentioned previously, the chart is for a single layer thickness. But what if I need to build up 1/8 of an inch or even 1/4 inch of thickness? Well, you can stack multiple layers of fiberglass on top of one another till you achieve your desired cross section. You can stack multiple thin layers, fewer thicker layers, or even mix and match the two to achieve your desired thickness. So say we're trying to achieve an 1/8 inch thickness. What I've done is I've laid up 2 different panels, one of which is 3 layers of our 737 fabric, which is a 17-ounce biaxial, and then 3 layers of our 10-ounce fabric, which goes by the number 745. The second panel I laid up is 3 layers of our 738 fabric, which is a 17-ounce biaxial with a 3/4 of an ounce chop strand mat stitched to the back. After the panels were cured and cut, we measured to find out how close we actually got to our desired 1/8 of an inch thickness. We got fairly close, coming in to 0.136 inches thick for both panels. In summary, thickness plays an exponential role in the stiffness of a laminate. That's why in a repair, we recommend you match the repair thickness to the original thickness of your laminate. You can get that thickness by calculating it out, creating a handy thickness gauge, or using our chart. Just remember that our chart is for one layer, hand laminated, and if you're going over one layer, you can mix and match your fabrics to achieve the final thickness that you need.